In this lesson, we will be graphing quadratic functions in vertex form. So in example 1, first we want to practice finding y-intercept. To find the y-intercept, we substitute a 0 in for the x value. Remember, y-intercept is wherever a line or any type of function crosses the y-axis. So that is always going to be where the x value is 0. All right. It says find the y-intercept for each quadratic function, and note that in part A we have a quadratic function in standard form. Part B we have a quadratic function in vertex form. So in standard form here, if I plug in a 0 everywhere I see an x, I'm going to get y equals 0 minus 4, so y equals negative 4. And my y-intercept is 0, comma, negative 4. A trick for that is you basically just look at that c value. In standard form, you can always just use 0, comma c. So you really don't have to do all that work. You should be able to just look at an equation in standard form and see that negative 4 value for c is your y-intercept right away. You don't have a shortcut trick like that for vertex form. Okay, so you have to actually plug in the 0 and do the math. So y equals 0 minus 3 squared minus 4. When I take 0 minus 3, I get negative 3. And then when I square negative 3, negative times negative is positive. 3 times 3 is 9. And then, excuse me, 9 minus 4 is a 5. So my y-intercept would be 0, comma 5. Notice that you can't get that just by looking at the numbers up here. Those numbers tell you your vertex, so you know your vertex is 3, comma, negative 4. But to get the y-intercept, you have to plug in the 0 and do the work. So just to kind of compare between standard form and vertex form before we move on to vertex form today, if you look at part A, you can't see the vertex just by looking at an equation in standard form. You can see the y-intercept very quickly. You'd have to do a little work to get the vertex using opposite of b over 2a. Then vertex form is kind of the opposite of that. The vertex is very easy to identify, and then you have to do a little bit of work to get the y-intercept. So as far as graphing, whether you're doing standard form or vertex form, I don't think one's necessarily easier or harder than another, but it's just for one of them, the vertex is easy to find and the intercept's a little more work, and then for the other, it kind of switches. All right, so let's take a look now at example 2a. We're going to find the vertex and the y-intercept using the equation, and then we're going to graph the function using at least 3 points, and then at the end, after we have that graphed, we'll state domain and range. So for part A, the vertex, since this is vertex form, is positive 3, positive 6. No work required there. Y-intercept is what we just learned in example 1. I'm going to plug in a 0 where I see x. And so I have y equals negative. 0 minus 3 is a negative 3. When I square it, I get a 9. And then I have a plus 6. So negative 9 plus 6 is negative 3. When I write y-intercept, I'm going to write that as an ordered pair, 0, comma, negative 3. All right, now, what you have to be really careful about is if you just go and graph these 2 points, 3, 6, which would go here, and 0, negative 3, which would go down here, there's 2 different ways we could connect these. We could do this, or we could do this. So you have to pay extremely close attention to which one of these was your vertex. So our vertex was up here at 3, 6. Probably not a bad idea to right away draw an axis of symmetry through your vertex, because then you know your graph should be symmetric over that dashed line. So now when I had the y-intercept at 0, negative 3, I could reflect that point over that line of symmetry to the other side at 6, negative 3, and then use the vertex to draw a curve passing through those 2 points. All right, now another thing is when you look back at the problem in part A, it did have a negative in front, which should have told us right away this is opening down. And sure enough, it is. Okay? So to finish up here, our domain Well, we look from left to right. There's arrows in each direction, so our domain is all real numbers, negative infinity to positive infinity. We will use interval notation for this. The range, if I look lowest to highest, the lowest y value is negative infinity because I have arrows pointing downward. But then the highest is the y value of my vertex, which is a 6. That will have a bracket because we have a closed point there. We've done domain and range in Unit 3, so now we're just reviewing that. The nice thing, though, is anytime we're graphing a quadratic function, which is a parabola, the domain will always be all real numbers, negative infinity to positive infinity. And then your range, it just depends on if it's opening up or down, whether you go negative infinity to the vertex or the vertex to positive infinity. But for the vertex, we're just looking at that y coordinate since the range looks at all the y values. All right, we're going to do one more example. Part B, vertex, I look at opposite, same. I have 1, 0. Right away, I'm going to graph 1, 0, and I'm going to draw an axis of symmetry through that. For the y-intercept, I'm going to plug in a 0 for x and simplify. 0 minus 1 is negative 1 squared. I get a positive 1. So 2 times 1 is 2. So I have 0, 2. So if I put a point at 0, 2 and reflect it over the axis of symmetry, then I can connect. Notice I have the 3 points I need, and it is opening up, and it is a little bit narrower because of that 2 in front. So just look at that a value to kind of check that your graph looks correct. And really, we're not using that to do the graph. We're just using vertex and y-intercept, and then just kind of using that a value to make sure it's opening in the correct direction and all that. All right, so for domain, like I said, it's always negative infinity to infinity. Left to right, there's arrows. Now the range, this one's opening upwards. So look at the vertex. That y value is a 0. That goes in a bracket, and this is then going up to infinity. So lowest to highest, we start at the vertex and then go up to infinity. The arrows are pointing up, so there's our range. All right, that concludes our lesson on how to graph quadratic functions in vertex form.